In this example, we have matrix A is 1, 1, 1, 1. We need to solve x prime equal to A times x. So the very first step is try to find the eigenvalues and eigenvectors. So we compute lambda A minus lambda I equal to 0. 1 minus lambda 1, 1, 1 minus lambda 1 minus lambda square minus 1 1 minus lambda, so 1 you can think of it as 1 square minus 1 and times 1 minus lambda plus 1. So minus lambda 2 minus lambda is 0 even though if lambda is 0, say lambda 1 is 0, lambda 2, or I prefer to lambda 2 is 0, so that's lambda 1 is 2. It doesn't matter, but let's choose it. Lambda 1 is 2, lambda 2 is 0. Yeah, so just a remark. Alright, we don't use that, but the matrix has an eigenvalues which is 0. This matrix is not invertible. Yeah, you can see that immediately this row is the same as this row. Or in the case that one row is the multiple of the second row, for example, then it's not invertible. In this case, one eigenvalues is 0. Anyway, we have two eigenvalues, one of them is 0. So eigenvectors, now we find eigenvectors correspond to lambda 1 equal to A minus 2I, say V1 equal to 0, A minus 2I, A minus 2 times I, minus 1, 1, 1, minus 1, A minus 2I. So say we need to find AB, so that V we can write as AB, two components, equals 0, 0. This matrix is actually rows equivalent to 1 minus 1, 1, 0, 0. So this gives us minus A plus B is 0. A equal to B. So any vectors of the form AA will be A1, 1. Not 0 vectors will give us an eigenvectors. So V1 we choose to be 1, 1. So that is for lambda equal to 2. Now lambda equal to 0. Lambda 2 equal to 0. You do the same thing. The matrix now minus 0, so it's the same. A minus 0I times V2 equal to 0, 0. So V2 say AB, so you have this one row equivalent to 1, 0, 0, 0. AB equal to 0, 0. Thus give us A plus B equal to 0. A equal to minus B. So any vectors of the form A minus A, or B minus B, B multiple of minus 1, 1 will give us an eigenvectors as long as that vectors is non-zero. Choose V2 to be minus 1, 1. Now we have a solution. We have two eigenfunctions. Function 1, v1 e lambda 1t. In our case, 1, 1 is lambda equal to 2t. The second one, v2 e lambda 2t. In our case, lambda 2 is 0. So we have just v2 minus 1, 1 times 1, e to the 0. So the general solution, xt c1 times f1, c2 times f2. So c1 times this plus c2 times this. C1 plus C2. Yeah, so this is a solution. Now let's sketch the solution curve. So just sketch a few trajectories. X1 and X2 with two eigenvectors. The first one is 1, 1. V1 is 1, 1. 1, 1. These vectors. Now extend it. We have the whole eigenspace. Second one is minus 1, 1. And we note that V1, 1, 1. Along V1 is go off infinity because lambda 1 e2 is positive. 2t is tend to infinity. Go off infinity. The other vectors minus 1, 1. Minus 1 here. So that vectors v2 with this one. Now you extend it to get the eigenspace. So when the coefficient c1 is 0, the solution will be along c2 times this vector. So just c2, just for example, c equal 2, you have minus 2, 2. So just one point like that. So depending on the values, it is independent from t. There's no t here. So in case this is 0, it is just a point on this line. Now we have a remark. When t tends to minus infinity, this one tends to 0. This one tends to 0. Xt will tend to the point c2 times this, depending on c2, it just tends to 1 point. Second thing is that if I write for the general case, if you have v1 e, maybe let me write for the general case, c1 v1 e lambda 1t c2 v2 times 1. So if you have t tend to minus infinity, lambda 1 is positive, in our case it is 2. This e lambda 1t or 2t tend to 0 when t tend to negative infinity. This whole thing tends to 0. This one tends to 0. Xt tend to the point C2, V2. So just when t tends to minus infinity. So for each values of C2 is we go to 1 point. That's the one thing. Second thing is that for t is big, or for any t, this one dominate. Here is something times v1 plus a number. Vectors contain two entry, two numbers here. So this is parallel to v2 the whole time, or to v2, v1 the whole time. xt parallel to v1. One is not 0. For c1 is 0. It just for c1 is 0. It just is to this point on this line. And c1 is 0. xt is just c2 v2. So you see that the whole time is parallel to the red curve. And when it tends to infinity, this go off infinity. And for negative infinity, just at 1 point here, right? Tend to this point. So the picture we see look like this. I can just copy this line. It would look like this. So that's what we see. Now we have the other side, go off infinity, the other side. So that's what we see in general. Yeah. So this is a picture when we have one positive eigen values lambda 1 and the other one is 0. Eigenvalue 0.